from differences to the differential quotient. I'm now putting into the playlist from seconds to tangent slope, basically the groundwork before you then do the quick differentiation. You know, f of x is x squared, then f prime of x is the exponent is multiplied to the front, 1 is subtracted from the top and remains. I don't write the 1 anymore, that would be the derivative which gives the slope, yes, the slope m at any given point. I'll derive it here again as an example. If you need more input on that, I would go to the playlist. Otherwise, you can go straight to differentiating. And everything else related to it accordingly, probably. So, curve sketching f of x equals x squared. And now you're supposed to I'll just pick any point up. I'll make that clear here. Yes, something like that, the standard parabola. Now you pick any point A here. And first, you use the difference quotient. Differences. So two differences minus quotient divided. How do we get there now? I move to a point further to the right, namely a plus h. I'm using the h method here. Yes, because that way I can draw a line which is initially equal to the slope of the secant. And then I let this distance h from a to a plus h approach 0. That means we now have the 2 points a and a plus h. If I plug in a, then I have a squared, and if I plug in a plus h, I have a plus h squared. I know this is pretty complex, but if you stick with it at the beginning and do a few practice problems, you'll actually get through it easily. Because now, you know, the slope between 2 points is basically y2 minus y1 over x2 minus x1. And there we have two differences and a quotient. And accordingly, here we have y2 minus y1, yes. That would be y2 minus y1. The chosen x values are plugged in here. These are the y values. So we have a plus h squared minus a squared over. And then accordingly, x2 minus x1, a plus h. I'll write it all out, minus a. So what remains down here is h. So we have a plus h squared minus a squared over h. And that first represents the slope of the secant. So the secant slope m through these 2 points. Now I'll expand the numerator here. That would be a squared plus 2ah plus h squared minus a squared over h. That's what it would be. A squared cancels out. Then we have h squared plus 2ah over h. That would be the same as if we factor out h in the numerator, h plus 2a over h. Now we can cancel h here, and then what's left I'll write here is h plus 2ah like this. And what happens now? The slope of the secant, in order to get the slope of the tangent at the point h. Now comes the limit. We let h approach 0 so that a plus h is the distance here, becomes 0. That means if we now let the limit as h approaches 0, for this expression h plus 2a, yes, what happens then? We're left with 2 and 2a, you can already see, yes, that would be the derivative, that's the differential quotient. And then you're basically at the topic once you've done this a few times, maybe also with a function of the 3rd degree, maybe even of the 4th degree. It's a bit of calculation, but then at some point you see the pattern, and then you're at the topic of deriving, differentiating, and then it goes on from there. Yes, you recognize the math term, danger averted. With some practice, you'll get through it easily.